Good day, I'm Maile Maziba. Welcome back to our channel. Today we're going to be continuing with our section 2 where we're going to be looking at example 2.5.1. Now going straight to the question, it says that calculate the average mole mass of a mixture consisting of 14% nitrogen, 26% oxygen, and 60% CO2. Now, looking at such a question, because they say they want the average mole mass, the first question I think it would be wiser that the first thing we do, we write the equation of the average mole mass. So the equation of the average molar mass is equals to let me call it molar mass of N2 multiplied by mole fraction of N2 plus molar mass of O2 multiplied by mole fraction of O2 plus molar mass of CO2 multiplied by mole fraction of CO2. Now this is actually an equation for average mole mass specifically for this question. So now looking at the question, the first thing that when we look at the equation, we realize that we're going to be we need the molar mass and we also need the mass fractions. So the first thing we need to do is actually to calculate the mole fractions. So let me just write the step 1. Calculate mole fractions. So we can just plug them in our equation. So now for us to be able to get or to calculate the mole fractions, there's something that is very much important for this question. It's like it holds the key to the whole question, is the fact that they said that it's in volume basis. And what we know is that when the ideal gas law holds true, it's not mole basis, sorry, I beg your pardon, it's actually in volume analysis. So we know that when the ideal gas law holds true, the volume analysis equals to the mole analysis. So may I just write it down? We know that when the ideal gas law holds true, volume analysis equals mole analysis. Now this means that the mole percentage of N2 is equals to 14% and the mole percentage of O2 is equals to 26% and the mole percentage of CO2 equals to 60%. So the volume analysis equals to the mole analysis. That's when the ideal gas law holds true. And we already know that in CIR 113, our assumption is that the ideal gas law holds true. So now, going further, continue with the question. One thing we also, what we need to do now is or rather, let me say, remember that we're calculating the mole fractions. Now that we know the mole percentages, we can actually be able to calculate all the mole fractions of each and every single one of these elements or compounds. So the mole, let me say, mole fraction of N2 is equals to 14% over 100%. That makes it 0.14. The percentages cancel out, and now the mole fraction of O2 equals to 26% over 100%, and that makes it 0.26, and the percentages are out. Now they're no longer percentages, they're fractions. So also lastly, the mole fraction of CO2 equals to 60% over 100%, and that makes it 0.6. Now we have the mole fractions, and in our equation we know we need the molar mass by the mole fractions. Molar mass, mole fractions, molar mass, mole fractions. So now answering the question, now that we have the information that we need, we're going to say, just rewrite the equation. Average mole mass is equals to, well, the molar mass of N2 is 28. So I can just put it as 28. It's actually 28 grams per gram mole, or pounds per pound mole, or kilomole. Yeah, either grams per gram mole or kilomole or pound mole, whatever it might be. So I'll just write it down. I want to write it down in full, and then yeah, so I'll just say 20, or let me just write it just to explain it. Let me just say 14 by 2. Yeah, that is actually 28 multiplied by the mole fraction, which is 0.14, plus, now we come to the oxygen. The oxygen, the molar mass of oxygen is actually 16, and it's gonna be 16 by 2. So it's 16 by 2 multiplied by, sorry, this is a 14 here, multiplied by 0.26, and then we have plus CO2 is actually 44, because it's carbon is 12 and oxygen is 16 by 2, so it's actually 12 plus 16 by 2, so multiplied by also the mole fraction, it becomes 0.6. and here, if you actually get the answer through the calculator, it should be 38.64 grams per gram mole, or you can just say 38.64 or 39 if you want it that way. So that is basically how to answer, or an easier way of answering example 2.5.1. and yeah, thank you for your time, and I hope to meet you again in our next video.